Gravitational potential energy. Earth of mass m. Now we move a body of mass m from infinity to a point P by doing a work W. Gravitational potential energy of a body at a point is defined as the amount of work done in bringing the given body from infinity to that point against gravitational force. Let a body of mass m is placed in the gravitational field of a body of mass m. The small work done by the gravitational field in moving the body of mass m through a small distance dr is dw equals modulus of f dr equals gmm upon r square dr. Here the external force equals and opposite to the gravitational force. So work done by the external force, but it's equal and opposite to gravitational force. So we substitute the formula of gravitational force. If the body m moves from R1 to R2, then we integrate for finding the total work done. W equals integration R1 to R2 gmm upon r square dr. After integration, we get gmm multiplies 1 by r1 minus 1 by r2. By definition, if r1 is infinity and r2 is r, then the work done equals the potential energy. The potential energy of a body located at a distance r from the center of the earth is epsilon equals minus gmm upon r. Case 1. If r2 is less than r1, then m can move from r1 to r2 without any external work. Here work is done by the system spending its internal energy, and hence work done is said to be negative. The potential energy decreases. On the other hand, case 2. If R2 is greater than R1, then work has to be done against gravity to move the object from R1 to R2. Therefore, work is done on the body by the external force, and hence work done is positive. Potential energy increases and becomes zero at infinity. Gravitational potential energy near the surface of Earth. Here R1 equals the radius of Earth r, and R2 becomes r plus h. If the body close to the earth surface R1 equals r and R2 equals r plus h, then the change in potential energy del U equals gmm multiplies 1 upon r minus 1 upon r plus h. Del U equals gmm upon r multiply 1 minus 1 upon 1 plus h upon r. On further simplification, we get del U equals gmm upon r multiply 1 minus 1 plus h upon r to the power minus 1. By binomial expansion and neglecting higher orders, del epsilon equals gmm upon r multiply 1 minus h upon r. Del epsilon equals gmm upon r multiply h upon r. And we know that gm by capital R square gives the acceleration due to gravity g. So del epsilon equals mgh. It is to be noted that potential energy difference has the physical significance. Potential energy of a system of three masses. Here you have three masses M1, M2, M3. M1, M2 separated by a distance of R12. M2, M3 are separated by a distance of R23. M1, M3 are separated by a distance of R31. So epsilon equals minus G M1 M2 upon R12 plus G M2 M3 upon R23 plus G M3 M1 upon R31. For n particles system, there are n multiply n minus 1 upon 2 pairs in the bracket. Thank you.